So, if an electron at a certain distance from a charged particle is attracted with a certain force, how the force compare at twice the distance? As I told you, if you increase or if you double the distance into twice, what will happen with the distance? The distance, twice the distance that we have the force, it will be 1/4 as much the previous one. Why? Because the distance, it has an inverse square law. Increase or double the distance, it means it will be 4D. But since it is in fourth and inversely proportional with it, it will be fourth of D. It will be 1/4. If you now triple the distance, what you will say? It will be like this. It will be F is K Q1 Q2 over D squared. But instead of D now, you have to write 3D squared. So it will be increased to what? Oh, it's equal to what? 1/3?
1/3.
It's 3D squared.
1/9.
1/9, the old force. So if you now treble the distance, the force will be 1/9 as much as the previous old force or the old force. Now, in this charged particle, look at them here. You have an electron that they have a distance attracted with another a charged particle is attracted with a certain force. Is the charged particle, so here you have electron that has an attractive force with another object. This object is charged, sorry. So what will be the charge of this object here? If they are attractive, if this is a negative,
positive, the other one.
It will be positive. It will be a proton. So if the first one is negative and the both of them now have an attractive force, attractive, it's happen only if you have an opposite sign. If the first is electron, negative, the second one, it will be positive, proton. Is it clear?
Yes. Yes, teacher.
Now let's solve some examples here. Shown below are 3 separate pairs of point charges, pairs A, B, and C. Assume the pair interacts only with each other. Rank the magnitude of the force between the pairs from largest to smallest here. The first one, we have 4Q and 2Q, and the distance between them is X. The second one, we have 3Q and 3Q, and the distance is X. And the last one, we have 2Q with 2Q, and the distance is X/2. Let's now rank them from the largest to the smallest force. Let's find first force of A. Force of A here is K, Q1, which is 4Q, times 2Q, which is the second Q, over the distance between them, which is X². So it is 4 times 2 is 8, 8, K, Q1, and Q2 over X². Let's talk about now F at B. It is K, 3Q times 3Q over x squared. That means it is 9
9
K
Q
Q
Q1
x squared.
Q2 over
This
x
is
squared.
F at B. Let's talk about F at C now. We have K, 2Q times 2Q over x over 2 squared. This x over 2 squared, it can be written as x squared over 4. Is it right?
Yes, teacher.
So if you, then now, you can write it now as 4 q times 2q times 2q over x squared. Just write the reciprocal of it. And after that, you can say also it is it is 4 times 2 times 2, which is 16, k q1 q2 over x squared. So look at them now. F of a is 8 times k q1 q2 over x squared. Fp is 9 times this magnitude, and Fc is 16 times this magnitude. So which is the largest one?
B. Sorry, C.
So it will be now f of c is greater than f of b is greater than f of a. Is it right?
Yes, teacher.
So what does it mean? That means if you have, or if you may put the two charged particles that have a distance d between them, the force, it will be greater than if you make them, or if you make the distance between them is half the distance between the first one. Like, which two particles have greater attractive? If we have 2 meters between them or 0.5 meter between them, which force will be greater? If the two particles are separated by 2 meter, or if the two particles are separated by 0.5 meter?
By 2 meter.
0.5.
Why 0.5?
Smaller.
Yeah, because we said that there's the force has an inversely proportional with the distance. That means if you increase the distance, the force will be decreased. Here, force is K Q1 Q2 over T squared. If the distance will increase, the force will be decreased. Or that's why the distance or the two particles that are separated by 2 meters, the force will be less than if they are separated by 0.5. So from this question here, as you see, we see that the force of any particle here, it depends on the distance or the square of the distance and also the magnitude of the charged particle. Look at the first one. Even though we have 4 and 2, the product of them is 8, and here the product of them is 9, and here the product of them is 4. Product of the charges, but the distance here will affect. Since the distance now at C is less than A and B, since now these two particles are separated by a distance that's less than A and B, so it has a greater force. if at C is greater than B and greater than A. Is it clear before going to the next question?
Yes, teacher.
Okay. Now, consider two small charged objects, one with a charge of 15 microcoulomb and the other of unknown charge. Here we have two charged objects. One is 15 microcoulomb and the second one, we don't know its the magnitude of its particle. When they are separated by a distance of 1.2 meter, the force is 2.8. So what is the charge of the second object? Let's say force is K, Q1, Q2 over G squared. Now, the force here is given. It is 2.8 is equal to K. What is the magnitude of K? Constant K.
9 times 10 to the power 9.
9 times 10 to the power 9. Times Q1, it is 15 microcoulomb, which is -6, times Q2 is unknown, over the distance, which is 1.2 squared. Now, 2.8 times 1.2 squared, let's multiply them now. You have 4.032 equal 9 times 15, which is 135 times 10 to the power 3 times the Q. I want only Q. Let's divide by 135 times 10 to the power 3. 135 times 10 to the power 3. We will see that Q here now is 2.9 times 10 to the power -5. 2.9 to the power -5 to the power 10 to the power -5. I want it in microcoulomb. What I have to do? I want it times 10 to the power -6. I want it in microcoulomb.
We will multiply the -5 by -6 or minus the
Multiply by
10.
10.
If you multiply it by
10.
10.
10 to the power of -1.
okay, we did it this one, but what will happen with 2.9?
Change the sign or multiply it with number يعني.
No, I mean that this is 2.9 times 10 to the power -5. I want now to convert it to be as a number times 10 to the power -6 because I want to write it in microcoulomb. What the number will be? It will be 2.9 or 0.29 or 29.
29.
0.29.
0.29.
Look here. if you have this number, okay, I want you to write it as the numerator 1000. What did you do with this number without changing the magnitude? يعني to keep it as 0.32. If you have to add 0 in the denominator, you have to add 0 in the numerator. Is it right?
Yes.
Here, it is
Yes,
32
teacher.
over 100. This 32 over 100. If I'm asked you now to write it now, but with the denominator of 1000, what do you have to do? You have to change the numerator to keep the magnitude as it is. Since you add 0 to the numerator, you have to add 0 to the denominator. So this one, it's written as 32 times 10 to the power negative 2. And the second one, it's 320 times 10 to the power negative 3. Both of them have the same magnitude, as you see from the fractions here. Because if you cancel the zeros, you will have the old number here. Here also you'll have the same. It is 2.9 over 1, 2, 3, 4, 5. I want you now to write them with 6 zeros because it is 10 to the power negative 6. So what you have to do, since we add 0 or multiply by 10 down, you have
You have to add
multiply
a
by
0
10,
up.
so it will be 29. So this number, it will be written as 29 times 10 to the power negative 6. Why? Because at the final or at the quiz here, if I give you the answers in micro, I'm asking you to write the answers in micro column, you didn't write this number for me. You have to tell me it's a 29 micro column. Is it clear?
Yes, teacher.
So the micro column will always be -6.
Yes.
Teacher, I have one question, please.
Yes, dear.
Here, 4.032 equals the other equation. ليش is it not 2.8?
Here, if you remember, it was like 2.8. Wait, please, let's clear here. It was 2.8 equal 9 times 10 to the power 9 times 15 to the power negative 6 times the cube over 1.2 squared. So if you multiply 2.8 times 1.2 squared, you get 4.032.
Okay.
Got it?
Yes.
Now is it clear? Here, I give you the force, I give you the magnitude of the first charged particle, and I'm asking you to find me the magnitude of the second one. Is it clear?
Yes, teacher.
Yes, teacher.
Okay. Here now, proportional reasoning. Consider a pair of electrically charged coins suspended from insulating threads a certain distance from each other. There is a specific amount of electrostatic force between them. If the charge of one coin were halved, what would happen to the force between them? Let's see here. Let's do A now. F, or let's say talk about the old one. The old one, or say the original force, is like K, Q1, Q2 over D squared. This is the original one. Now, what happened if the magnitude of the second charge is halved? It's like F Q1 Q2 over D squared, but the magnitude here is half. What will happen with the magnitude of the force?
It will be doubled.
Doubled? Look at the relation. What is the relation between the product of forces,
Sorry.
between the product of charge and the force?
Teacher, the Q is halved.
Half, yes. Half, Q1, Q2. What will happen with the force?
It will be halved.
Yes, the force, it will be halved.
But
Because
teacher, if the K is halved,
the K cannot be halved. It's a constant.
صح.
So A, it will be halved. B, if the charge on both coins were doubled, and both coins were doubled, what does it mean? That's mean I have K, here we have Q1, Q2 over D squared, and in both of them it's doubled. What will happen with the force here? It will be what?
Doubled also.
Doubled?
It will be 4F.
Yes, it will be quadrupled. Why? Because 2 times 2 is 4. So it will be 4 2 times the original force. Now see, if the distance now between them were tripled, the distance now is tripled, what will happen with the force?
Can I say?
Will
Yes.
be 1/9.
Yes.
It will be 1/9, the original number, the original force. So it will be 1/9. Now D, if the distance between them were reduced to 1/4 of the original distance, that's mean here F, K, Q, Q, but it's not D, it's 4th D squared. If the original, or if the distance now will decrease to 4th D, what will happen with the force?
It will be multiplied by 16.
Thank you. It will be 16 times the original number. Now let's talk to E. If the charge of each object were doubled, that's mean here F if the charge is doubled, here is 2, here is 2, were doubled, and the distance between them also were doubled. What will happen with the force?
4 teacher.
Eh?
4 multiplied by 4.
Before.
To stay the same.
It will stay the same. There's no change. Thank you, Danny. Because here we have 2 times 2 is 4 over 2 squared, which is 4. 4 cancel 4, so it will be the same. Is it clear?
Yes.
Okay, let's try the answers now. A, the force will be halved. B, it will be quadrupled. C, the force would be 1/9 the original value. D, it will be 16 times the original. And E, it will be, or you can say there's no change, or it will be the same. This is the answers of them. Now, maybe after list